Welcome to CO451 Networking. This is the third packet tracer exercise for week 2. This is implement basic connectivity. So this is the third packet tracer exercise for week 2, and it's going to be looking at how we put some connectivity together on our switch and PCs in a basic network. So let's switch over to the packet tracer exercise. And here we go. So implement basic connectivity. We have an addressing table at the top, and that's really important because that gives us our details about the addresses we're going to use. So we can see the IP addresses here. Tells us about the interfaces on the various switches. So switch 1, switch 2 on our two PCs, PC1 and PC2. We have the subnet masks that go with the IP version 4 addressing here. And then we have a set of objectives for this exercise. So part 1, we're going to perform a basic configuration on S1 and S2 switch. We're then going to do, in part 2, we're going to configure the PCs. And in part 3, we're going to configure the switch management interface. So the background to this one is, in this activity, you will first create a basic switch configuration. Then you will implement basic connectivity by configuring IP addressing on switches and PCs. When the IP addressing configuration is complete, you will use various show commands to verify the configuration and use the ping command to verify basic connectivity between the devices. So we get into some instructions here. So part 1, perform a basic configuration on S1 and S2. And we're just going to complete these following steps for S1 and S2. So configure S1 with a host name. We did this in the last exercise. So this is building on the first 2 exercises into this third exercise. So they now assume that you've had the commands to do this and you've had some practice. So they don't give you all the commands. They just ask you to start to implement things. So it's really important that you do remember what you've learned before in the previous exercises and can bring that to bear in this one. So S1 with a host name, enter the correct command to configure host name. And then what else do we need to do? We need to do in step 2, Cisco for a console password and class for a privileged exec mode password, which is the enable command. And then we need to verify the password configuration. So how do we verify the passwords were configured correctly? Well, we'll look in our running configuration file and then use an appropriate banner text to warn unauthorized access. And they give us an example of some text that we could use. In fact, I'm going to copy that text just to my clipboard because I think that would be saves a bit of time really. So we're going to use that exact same text for our things, if we can, our actual configuration. I don't know if that'll copy actually, but if not, I can type it in. So we need to do console password, privileged exec mode password, host name, and then just check the password is set up and put our banner on. So this is banner messages of the day, which we need to set there. And then it says save the configuration file to NVRAM, which is saving our running configuration file to the startup configuration file. And then repeat the steps for S2. So let's get started. Right, okay. So here's our little network diagram. Pick it up a little bit so we can see it a bit clearly. So S1, let's go in on the control, on the command line interface. From our console, so enable and configure terminal. And then host name S1. And then we're going to need to do our line console 0. and password. And I think they just wanted us to use Cisco for the console password. Again. Exit on that one. And then also the enable. And we'll do it encrypted. Secret class. Encrypted password on the enable command as class. And we should turn on our service password encryption just to make sure any other passwords that we add are also encrypted. And we should do our banner MOTD. I'll use the hash to delimitate it. And we'll put our message up. So authorized access only. And you must be authorized to use this secure system. There we go. That's my little banner message there. Okay, I think that's everything that they wanted within the setup. Let's just go back to the activity a second and double check that. So we did hostname, we did the console password, we did the privileged exec mode password. Didn't quite do it exactly the same for the banner, but that's good enough. And we're going to save the configuration file to NVRAM as well. So let's just finish off on that one. So save the file. Just exit. And in the privileged mode, show running config. Just to check that we did that. So there's the host name. There's our enable secret password. Come down a bit. There's our banner. And there's our line password as well. On the so let's save that. So we could do it a long way. Copy running config to startup config. Or we could just use our little simple right to build it out. And if you want to check that, we can just do show flash, and there's our config message on there. Good, so that one's done. So we can now move over to S2. So let's go on to S2. And do the same sort of thing. So enable configure terminal, hostname S2, line console 0, password go, login, exit that. Enable secret class. Service password encryption. And then banner MOTD. Oops. So authorized access only. You must be authorized to use this secure system. Okay, and then end. Show running config. There's my enable secret password, hostname S2. And again, if I come down, there's my banner message and my line console password. And then to copy running config to startup config, or write, and we can see that if we do the show flash, there's my config.txt file. And that's it. So both the switches are initially configured. Basic security options on them. Go back to the exercise here. So part 2, configure the PCs. So we need to configure PC 1 and PC 2 with IP addresses. So we need to go into PC 1, use its desktop, go into the configuration, IP configuration, use the tables at the top of this sheet to give them their IP addresses and subnet masks. And we need to do that for PC 1 and PC 2. So, and then once we've done that, we're going to go and see if we can actually ping our switches. So it's asking us to go to PC 1 and try to ping S1 192.168.1.253. So let's have a look first of all. So PC 1 is going to be 192.168.1.1, and PC 2 will be 192.168.1.2, and they're both what we call /24 subnet mask, so 255.255.255.0. So let's put this configuration information into our configuration here. So PC 1, just open that up. This is just like us going to Windows sort of desktop or control panel in Windows and setting up the IP configuration. So IP configuration, we're using just the IP, not IP version 6, we're using IP version 4, static configuration, and we're giving it an IP address here. So 192.168.1.1. And the subnet mask is going to be 255.255.255.0, and it puts that in because that's a default Class C subnet mask, and this is a Class C address, so it's just used that by automatically. We could change it, but we don't need to for this. That's what we want, so that's fine. And we can just close that. It will save that into the configuration. And then PC2. Let's find its configuration. So 192.168.1.2, and again 255.255.0, and again that will be saved. And then it asks us to do a ping, which is to test end-to-end connectivity. On the command prompt on PC 1, I can ping the address which is for the S1 switch, 192.168.1.253, and we can just run the ping and see what happens. So we've timed out on the first request, on the first packet. We've timed out on the second one. It'll do 4 by default, but I know where this is heading. This is going to time out, so none of these are actually working. So we're not able to contact the switch, and the reason is because the switch is not set up with any IP address to manage it. It has no management IP address on the S1 switch, so this is no really surprising. We're getting timeouts, so it's not set up yet. So we need to let's have a look at keep to the order of the exercise here. So what do they want us to do? So we've got our PC configurations. We're not able to ping anything because that's not working. So we need the switch management interfaces to be configured on S1, S2 with an IP address. So to do that, switches can be used as plug and play devices. This means that they do not need to be configured for them to work. Switches forward information from one port to another based on MAC addresses. If this is the case, why would we configure it with an IP address? Yeah, that's true. So you can just plug in the switch and it will work as a switch without you doing anything really to it. So it's kind of plug and play, like they say. So why would you want to manage it with an IP address or have a management IP address on it? Well, the reason is because obviously you want to be able to access the configuration remotely. So rather than being able to just plug yourself in with your laptop directly to the console port on the switch, you'd like to be able to manage that remotely over a network, so you don't have to go bundling off down to wherever the switch is and connect yourself directly to it. So in order to be able to manage that device correctly and configure it remotely, you're going to need to give it an IP address. So we've got the commands to do that. So the following commands to configure S1 with an IP address. So in the global configuration mode, we're going to need to go to this interface. This is a virtual local area network interface. So this VLAN is a virtual network, and all the ports within a switch are in VLAN 1 by default. So interface VLAN 1 gets us into this virtual local area network environment on the switch where all the ports are by default, and by putting the address on there, IP address 192.168.1.253 with /24 subnet mask 255.255.255.0, then it means that we're actually going to be able to contact this device as a device on the network, so we can actually get to it and configure it. And then the no shutdown here is to turn the interface on. Interfaces by default in industrial machines like this are shut down. So in order to bring them out of shutdown, to make them active, even a virtual interface, we need to issue the no shutdown command. So no, anything no just does the opposite. So shutdown, no shutdown will take it out of shutdown mode and make it operational. So let's do that. We also need to do the same for S2 as well. And S2's address is 192.168.1.254. Okay, so again, same subnet mask. So let's configure these ones. So this is a management interface we're going to put onto this device. So enable. Okay, so configure terminal interface VLAN 1. Like I say, is the default VLAN for this device. So any Cisco switch or router, in fact, is going to have a default VLAN, which all the ports are going to be in, VLAN 1. So let's put an IP address on this interface, 192.168.1.253, and then the subnet mask 255.255.255. VLAN 1, by the way, you shouldn't use it because it is default. You should actually immediately take everything out of VLAN 1 in terms of the ports and use others that aren't VLAN 1. Create your own with different numbering is obviously the best advice, but we're not there yet. We're only starting out, so it's easier to show this exercise at the moment because everything is in VLAN 1, so you don't have to worry about what VLANs are and how they work. You can just use the default settings to learn about setting up a management interface, but generally we should never really use VLAN 1. So let's bring it out. So no shutdown. And you'll see when you do no shutdown, you get a little command, little message come up here. It says link change, interface VLAN 1 change state to up, and the line protocol on interface VLAN changed up. So basically it says the interface itself is up and powered up and working, active, and the line protocol on interface VLAN 1 also changed state. That means it's plugged in and connected so that we can actually contact it, and the protocols will work with it. So that's it. That's the management VLAN 1 interface operational on switch 1. So we need to do the same sort of thing on switch 2. Well, in fact, on switch 1, before I do that, obviously I want to save that configuration with my configuration settings in the running configuration. So do end. End is a quick way of jumping back to the privileged exec mode. And I'm just going to use my write command to build out the configuration, so save from running configuration to startup configuration. And let's do the same with S2. So, well, we configure terminal and interface VLAN 1. IP address 192.168.1.254, and then 255.255.255.0, and no shutdown. And we get the message saying this one's up and the VLAN 1 line protocols are up as well. And write that from the running config to the startup configuration so that saved. Good. Let's go back to the exercise, what they want us to do next. Okay, so we've set up the PCs, we've set up our switch management interface, we've configured S2 with the same details. So verify the IP address configuration on S1, S2. Use show IP interface brief command to display IP address status of the switch port interface. You also use a show running config. Yeah, so this new one, show IP interface brief, another one of those commands that we use all the time. So let's go to S1 here. Again, we're on privilege mode. So show IP interface brief, and we can see all of the ports and 24 ports and the 2 gigabit ports fast Ethernet, and then at the bottom we have the VLAN, so VLAN 1, and this is the address that we put on it, and we can see that it's operational up and the line protocol is up as well. So that's how we can see that we've got a management interface on this device at 192.168.1.253. And as I said, we could check the running configuration as well. So show running config, and again we see all the interfaces, and at the bottom we see our interface VLAN 1 and the IP address for the management VLAN. And that's S1, and we would see the same thing for S2. So show IP interface brief. There it is, VLAN1. And we could show running config. And there it is there as well. So we can verify our management interfaces have been set up. Okay. So saved our configuration, verifying network connectivity. So network connectivity can be verified using ping. It's very important that connectivity exists throughout the network. Corrective action must be taken if there is a failure. Ping S1 and S2 from PC1 and PC2. And it tells us to click PC1, desktop tab, command prompt. Note you can also use ping command on the switch command line interface and on PC2. All pings should be successful. If your first ping result is 80%, try again. It should now be 100. You will learn why the ping may sometimes fail the first time later in your studies. If you're unable to ping any of the devices, recheck your configuration for errors. So yeah, let's just test our connectivity. So ping is a major command for testing end-to-end connectivity. So what we're going to do now. So let's ping, that should be the address for S1, which we did last time. This time we should now get a reply because we have a management interface on S1. There we go. It times out for the first one, and the other three go through. And again, if I ping next time though, it will go straight through. So there's a reason why that first one fails. It's learning the route basically. But we'll see. Let's ping S2. So again, we time out on the first one, but the other three go through. And if I do it again, it'll be quicker and they all go through this time. And then finally, let's ping the other end. So ping PC2. There we go. And we could do the same from PC2. We could also do the same from S2 as well. So, or S1 even. But let's just show you that. So privilege mode, ping 192.168.1.1, that's PC1. And it pings out a single ping for that one. And we could ping the other one. And we could ping 253. There we go. These will get better as we do it. So you can ping from the devices, switch devices as well. Okay, so we've verified our connectivity. I think that's everything to do in the task, for the third task here, on implementing basic connectivity. Yeah, that's it. So that one's complete. So hopefully you enjoyed going through that one. It just brings to bear all the things that we learned within the first and second exercises. Now in the third exercise, we learned a little bit more about configuring interfaces in this one with the switch management interface and our virtual LAN, our virtual local area network connection VLAN1. So moving forwards, just a little bit step at a time.